Hello guys, today we're going to be covering the SIMPLEX method of LPP, linear programming problem, which is basically optimization of a function. So I have an example here. So this is the function which we need to maximize, 3x plus 4y, and we're given constraints here. We have two constraints, x plus y is lesser than or equal to 4 and 2x plus y is lesser than or equal to 5, and we have two non-negative constraints, which is just both of the variables are greater than 0, which is generally the case. So let's solve this. Generally we solve LPP when it's lesser than or equal to 2 variables or 3 variables. We do it with the graphical method, but in the real industry, if we see, there are a lot of variables which go into which we have to factor in, which means here we can see that we have only 2 variables, but in reality we'll have 5, 6, maybe even 10 variables. So the graphical method is not feasible then, so we use this method, and of course it can be used for any number of variables here. So we're going to be using it here for 2 variables. This is the first example. There'll be another video coming shortly which is of 3 variables based on the same method, so stay tuned. So first what we need to do is, everybody thinks simplex method is very tough because it's not similar to the other mathematics which we do, but it's actually very easy. So let me just show you how we do it. First, all you need to remember is how to draw the table. So first let's see how the table is drawn. Let me just go down. We have, just try to by heart this, okay? We have this, we have a CB, we have a B, we have a XB, then we have the number of variables. Here as we can see we have 2 variables, x and y, and just for my simplicity I'm going to be taking x is equal to x1 and y is equal to x2. If you want, you can do it with x, y, z, whatever you have, but x1, x2 is what the convention is. So let me just take that. So now here you write the variable x1, x2. Now after this, let me just write the solution first. So the solution of this problem, we have this which we need to optimize, 3x1 plus 4x2. We have the constraints. These are inequality constraints. We need to convert them to equality constraints. So for equality constraints, we need to add what is called a slack variable. For lesser than or equal to constraints, if we have greater than or equal to constraints, we need to add something called as surplus variables. So here both of them are lesser than or equal to, so we're going to be adding slack variables which are denoted by S. So we need to add them here, x1 plus x2 plus s1 is not lesser than or equal to. Now we will write equality because we added the slack variable, is equal to 4, and in the second one 2x1 plus x2 plus s2, another slack variable, is equal to 5, and implicitly we don't mention it, but we also add it here in the optimization as 0 into s1 plus 0 into s2. So even if you don't write it, it's fine, but you can write it. And of course the x is greater than or equal to 0, y is greater than or equal to 0. That is understood. So now we need to add in this column here, back to the table, we need to add the 2 variables which we added, s1, s2. Okay, and on top here you can write cj, and let me just extend this, and now here you need to add whatever the we need to optimize. So here we have 3 and 4 for x1 and x2 respectively. So write here 3, 4 and the coefficients basically. So 3, 4, and here you can see for s1 and s2 it's 0, 0. So write 0, 0. Okay, simple. Now this is this part. Let me just go down. Now you add the 2, now you fill in the data. For CB first write 0, 0, by default add 0. For B is the variable you're talking about. So first the slack variables, s1, s2, write this. Then xb is the right hand side, which is 4 and 5. So write this 4 and 5 respectively. Now fill in this data. For the first one it is 1, 1, 1 and 1. So 1, 1, 1 and again here it's understood that it's S2 into 0, so just write 0. Same thing here, 2 1 1, so write 2 1 0 1, because you can see this is S2. So this I'm just taking it from this part here. If you didn't get it, this I'm just filling in this data here, 1 1 1 0 and 2 1 0 1, just filled in from here, and this is the right hand side, this has also been filled in from there only. Okay, now let's go back to solving. Now what you need to do is you need to find something called Zj, which is basically this CB into Aij. You'll ask, what is Aij? Aij is basically just this column, this and this. Ij, as we represent it in matrix format. So you just need to multiply these two and find out the sum. That's what it means. Let me show you. For the first column, CB, consider CB and x1. It's going to be 0 into 1 plus 0 into 2. That is the sum. So it's 0. Then you do the same for x2, CB into x2. 0 into 1, 0 into 1, 0. 0 into 1, 0 into 1, 0. 0 into 1, 0 into 1, 0. First, it's going to be 0 only because your CB is 0. Now, what you need to do is find Cj minus Zj. Sometimes they do Zj minus Cj or Cj minus Zj. You can use either one, but I use Cj minus Zj. What is Cj? These are the Cj values. This. And these are the Zj values. So, just do minus. So, 3 minus 0, 3, 4, 0, 0. Now what you need to do is the simplex table ends when Cj minus Zj, this is the condition, Cj minus Zj needs to be lesser than or equal to 0, all the values. So here you can see this is greater than, this is greater than, this 0, this 0, this is fine, but these are greater than, so it's not optimized yet. So this is the first simplex table. First simplex table. Now what you need to do is you need to find the correction factor, which is denoted by theta. Theta is xb, which is the right hand side value, divided by, you look at the Cj minus Zj, which is the greatest value here. This is the greatest value. So look at that. Now you need to, you know that the value will be somewhere in this x2 column here. So what you need to do is xb divided by x2. So 4 divided by 1, which is 4, 5 divided by 2, which is, the 5 divided by 1, which is 5. Now what you need to do is in the theta, look at the number which is the most least number, but still positive, not negative. So here we did greatest, here you see least. So here the least is 4. So now you just trace along this, trace from here, I'll just change the color, trace from here, this side goes till here and this side goes till here. Where does it meet? It meets at 1. So 1 is our, what we call as the key value. So this is our key value. Now what we need to do is we need to make the key value as 1. We need to keep it as 1. Generally we need to do some transformation, but here in the problem it's given as 1, so we don't need to do anything. Now we move on to the second step, which is writing the second simplex table. Okay, now again write the same thing, write CB, write B, write XB, write X1, X2, S1, S2, Cj, write 3, 4, 0, 0. This always remains the same. Now don't blindly fill in the values. Now what we did here was, after we found out that this is the key value, the hypothesis which we make is that x2 will be entering the table here, this part, and s1 will be leaving. This is entering and this is leaving. So instead of s1 now you write x2 and write this, the CB value will no longer be 0. That value is whatever is in the optimization coefficient. So here what is x2 is entering, so the coefficient is 4. So write here 4. And xb, what you need to do is, here everything is already the same, so just rewrite this 1 1 0 1 4. Okay, extend this. Now looking at this table, now second one, s2 will be as it is, s2 here 0. Now what you need to do is look at the value of s2 here. It is 1 over here in this table, it is 1. This needs in the key column here, this is the key column, the key element needs to be 1 and everything else in the key column needs to be 0. So we need to make this 1 as 0. So what do? We need to apply a transformation. So say this is row 1, this is row 2. So this needs to become 0. So one simple transformation we can do is R2 is R2 minus R1. Okay, so it will be 1 minus 1. So this will be 0. Now look here, 2 minus 1, 1. 5 minus 4, which is 1 again. This one, 0 minus 1 minus 1. This is 1. Okay, just the transformation is applied now. Now again same, find zj. Zj will be, now it will not be 0, it will be 4 into 1 plus 0 into 1, which is 4. 4 into 1 again 4. 4 into 1 again 4. This will be 0. Now you find Cj minus Zj. Now Cj minus Zj is 3 minus 4, which is minus 1. 4 minus 4 is 0. 0 minus 4 is minus 4. This is 0. Now we can see that Cj minus Zj is lesser than or equal to 0. This is, both of these are 0, both of these are negative. So our solution is now optimized, and our solution is basically these two values, this value and this value. So S2 doesn't matter because that is not in the optimization. So what we had to do was p is equal to 3x plus 4y. Substitute the value. From here we can find out that 4y, which we took as x2, so 3x1 plus 4x2. And from here we can find out the xb value. Just look at the xb value. So x2 equal to 4 and x1 equal to 0, since it's not in the table. These are the optimal values, and the optimal solution, substitute the value 3 into 0 plus 4 into 4. So the final answer is 16. Now let's see if that is correct. Simplex 1 answer 16. You can see it is correct. This is the answer. So this is how you solve simplex method 2 variable LPP. Thank you.